Good morning. Today we are going to discuss about the introduction to electromagnetic field. So electromagnetic is a common word. So we have two words. One is electrostatic plus magnetostatic. So the combination of electrostatic plus magnetostatic is nothing but the electromagnetics. So the electromagnetics deals with the interaction of charges. So we define the electromagnetic means it is a science. It will deals with the interaction of charges. Okay. Charges will be rest means that will be deals with the electrostatic. If charge will be motion means that will be deals with the magnetostatic field. This is for electrostatic field and this is for magnetostatic field. So these two quantities are vector quantity. So before going to discuss about the electrostatic and magnetostatic, we need the some basics of vector analysis. So first we are going to discuss about the vector analysis. So under this, first one is vector addition. So we can perform the vector addition. We have two methods are there. So already we have studied in your school itself. So one is parallelogram rule and another one is head to tail rule. Here we are going to consider the parallelogram rule. We are considering into the two vectors, that is A vector and B vector. So we are adding into these two vectors, means first we can draw the parallel lines for these two vectors. So this is for B, parallel for A vector, and this is parallel lines for B vector. Now we are adding into these two vectors, means the diagonal of parallelogram is addition of two vectors, that is C vector is equal to A vector plus B vector. Okay. So second one is vector subtraction. So again we are considering into the same two vectors. This is for A vector and this is for B vector. So we are going to perform the C vector is equal to A vector minus B vector. So how we are going to perform the subtraction means we are going to perform the addition A vector plus minus of B vector. So here we have two vectors A and B. So A vectors already is there, but we need the minus B vector. So how to take the minus B vector means we are going to take the one out of 180 degree of B vector. So this is for minus B vector. Now we are going to perform the again addition operation with the help of the parallelogram rule. First we can draw the parallel lines for B and parallel lines for A, and this is the C vector. So C vector is equal to A vector minus B vector. And the third one is vector multiplication. So we have two types of vector multiplications are there. One is scalar multiplication or second one is vector multiplication. Vector multiplication or cross product. We have two types of multiplication. Vector multiplications are there. One is scalar multiplication and another one for vector multiplication. So first we are going to discuss about the scalar multiplication. So first one is scalar multiplication or dot product. Dot product. Let us consider the two vectors A vector and B vector. So A vector is equal to Ax along the unit vector Ax, Ay along the unit vectors of Ay, Az along the unit vector of Az. So Bx along the unit vector of Ax plus By along the unit vectors of Ay plus Bz along the unit vectors of Az. Now we are considering into these two vectors. We are going to perform the dot product means. So A vector dot B vector is equal to modulus of A, modulus of B and cosine angle between the A, cosine angle between the A, B. Okay. So first we are taking into the modulus of A and modulus of B. So A vector dot B vector is equal to Ax along the unit vector Ax plus Ay along the unit vector of Ay plus Az along the unit vector of Az into B vector. So Bx Ax plus By Ay plus Bz Az. Okay. Now we can take the dot product means. So Ax into Ax, Bx into Ax dot Ax plus Ay Bx Ax dot Ay plus Az Bx Ax dot Az plus Ax By Ax dot Ay plus Ay By Ay dot Ay plus Az By into Ay dot Az plus Ax Bz Ax dot Az plus Ay dot Now these two are magnitude, so we are writing into directly. So Ax Bx. Now we have these two, we are going to take the dot product of these two vectors. For example, we are considering into Ax dot Ax is equal to modulus of Ax cosine angle between the AB. So unit vector of Ax will be 1, 1. Now we are considering into the angle between x. Both are same coordinates. So the angle between these two will be 0. So cos 0 value will be 1. So Ax dot Ax value will be 1. Similarly, Ax dot Ay is equal to, so modulus of Ax, modulus of Ay, cosine angle between the Ax and Ay. So unit vector value will be 1 and cosine angle between x and y. We are considering into the three coordinates, that is x, y and z. So these three coordinates are mutually perpendicular to each other. So Ax, Ay value will be 1, that is of unit vectors, and cosine angle between 90 degree. So why I am taking into 90 degree means mutually perpendicular to each other. So cos 90 value will be 0. So 0 into anything will be 0. Similarly, Ax, Ay value will be 0. Ax, Az value will be 0. Similarly, Ax, Ay value will be 0. Again, we have a Ay dot Ay. How we have taken into Ax dot Ax value 1. Similarly, Ay dot Ay value will be 1. So Ay by plus Ay Az value will be 0. Ax Az value will be 0. Ay Az value will be 0. So Az dot Az value will be 1. So Az and Az. So this is the value of A dot B. So we get only for the magnitude value alone, so that this vector is called, this product is called the scalar product. Okay. So second one is vector multiplication. Vector multiplication or cross product. So as per the definition of cross product, so we are considering into two vector A cross B. We are going to take the cross product of these two vectors. A cross B is equal to modulus of A, modulus of B, and sine angle between A and B along the unit normal vector. So let us consider the two vectors A and B. Let us consider the A vector is equal to Ax along the unit vector Ax, Ay along the unit vector of Ay, Az along the unit vector of Az. So B vector is equal to Bx Ax, By plus Bz into Az. Now we are taking into A cross B means A cross B means so AX, AY and AZ. The magnitude of A vector is equal to AX, AY, AZ, BX, BY and BZ. Suppose we are taking into the cross product AX cross AX means so modulus of AX sin theta AB sin angle of AX dot AX along the unit normal vector. Now the unit vector of AX will be 1, and the sine angle between the AX will be 0. So sine 0 degree along the unit normal vector. So sine 0 value will be 0 into anything will be 0. Similarly, we are taking into AX cross AY means modulus of AX, modulus of AY and the sine angle between AX, AY along the unit normal vector. So the unit vector of AX will be 1, unit vector of the AY will be 1 and the sine angle between AX, AY both are mutually perpendicular. So sine 90 degree along the unit vector. So sine 90 will be 1. So 1 into unit normal vector. For example, we are considering into this is for x-axis and this is for y-axis. Now we are considering into the unit normal vector will be AZ. We are considering into the x and y plane. The unit normal vector is AZ. So we get the AZ. So this is for AX cross AY value. Similarly AY cross AY is equal to 0 is equal to AZ cross AZ, AY cross AZ is equal to AX, AZ cross AX is equal to AY. So this is the vector multiplication or cross product. Any other doubt is there? We go on the next one. Fourth one is unit vectors. Let us consider the vector A. We are finding into the unit vector of A means A vector divided by modulus of A. So let us consider A vector is equal to AX along the unit vector AX, AY along the unit vectors of AY, AZ along the unit vector of AZ means so the unit vector A is equal to AX plus AY AZ divided by modulus of A means root of A x square plus a y square a z square. This is the here a vector divided by modulus of a. The unit vector will be represented into small a. This is the unit vector. So from this basic we are concluding into two vectors are parallel means case number 1, two vectors are parallel means A cross B is equal to 0. Case number 2, two vectors are perpendicular to each other means A dot B is equal to 0. So this is important 2 mark question. They will give the two vector. After that they will ask whether the two vectors are parallel or perpendicular to each other like that. So please make a note of it. This is for important 2 mark question. So this is the basics of vector. Next we are moving into coordinate system. We have two type of coordinates are there. One is orthogonal coordinate system and another one for non-orthogonal coordinate system. We are going to discuss about the orthogonal coordinate system. So what is meant by orthogonal coordinate system means, so all the coordinates are perpendicular to each other. All the coordinates are perpendicular to each other. So that type of coordinate system comes under the orthogonal coordinate system. For example, we have so Cartesian, cylindrical and spherical. Spherical coordinate system. So we are going to consider these three coordinate systems. For Cartesian coordinate system, we have one more name is that is rectangular coordinate system. The variables of Cartesian coordinate system is x, y, z. For cylindrical system, rho, phi, z. For spherical system, r, theta, phi. Here the x will be varied from minus infinity to plus infinity. Similarly, y will be varied from minus infinity to plus infinity. Z will be varied from minus infinity to plus infinity. Similarly, the rho will be varied from 0 to infinity. Rho is nothing but a radius of the cylinder, and y will be varies from 0 to 2 pi, and z will be varies from minus infinity to plus infinity. So y is nothing but of azimuth angle of the cylinder. Similarly, so the r will be varies from 0 to infinity. So theta will be varies from 0 to 2 by, and y will be varies from 0 to 2 by, theta will be varies from 0 to 2 by. The unit vector of the Cartesian coordinate system is ax, ay, az, and the unit vectors of coordinate unit vectors are ax, ay, az, a rho, a pi, az. For spherical system, ar, a theta, a pi. So these are all the unit vectors of different coordinate system. And the differential length is equal to, differential surface. So dx dy along the unit vector of az, dy dz along the unit normal vector of ax, dz dx unit normal vector of ay. For spherical system, rho into t pi into az, rho into d pi into az. So d pi dz along the unit vector of a rho d pi, dz along the unit vector rho d pi and dr. Similarly, we can find the surface of spherical system, okay, and also find the volume of the Cartesian cylindrical and spherical system by one, okay.